Today we are looking at Learning Target 9, which is Solving Equations, Day 4. The type of equations we're looking at today are solving with squares. So what I want to show you is a new way to organize Step 1, which is using order of operations backwards to determine which operation to cancel. What I've noticed is that on a couple of more unusual equations, some of you are struggling with which order to cancel your operations in. So what I would like you to do now is to actually write down what you would do to the x if you knew what it was. So we're looking at x squared plus 8. If I knew what x was, if I were going to check my answer and I substituted a value for x, the first thing I would do using order of operations is square it. So I'm going to put a little square over here. After I square it, then I would add 8. Okay, so I am going to use order of operations backwards. And how would I cancel adding 8? Subtract 8. So that's the first thing I will do to my equation. So I'm subtracting 8 to cancel the plus 8. Remember, on the side with the variable, we never actually perform the operation. We just use it to cancel and simplify and start to get the variable alone. So I'm left with x squared. 23 minus 8 is 15. Continuing backwards, what is the opposite of squaring? The opposite of adding is subtracting. The opposite of multiplying is dividing. The opposite of squaring is square rooting. So I'm going to take the square root of both sides. Remember, on the side with the variable, we don't actually perform the operation. We use it to cancel. Why did we take the square root? To cancel our square, leaving us with x. 15 is not a perfect square, so we just leave it as the square root of 15. All right, now we're going to check our answer, and this will be easier than you think. First thing we're going to do is substitute the square root of 15 for x. Now, I know most of you are thinking, well, I need to pull out my calculator to figure out what the square root of 15 is so that I can square it. But think about what we just did on this step. We used the square root to cancel the squared because they're opposites. We're going to do the same thing when we're checking. The square root and the square will cancel each other out, leaving us with 15. And 15 plus 8 is 23, so it checks out. We'll look at a couple more examples. Our next one, if I'm going to list the order of operations, if I knew what x was, I would first evaluate inside the parentheses, which is a minus 4. After I subtracted 4 from x, I would square it. So we are going to do these operations backwards. What's the inverse or the opposite of squaring? Square rooting. So the first thing I will do is square root both sides. Why am I square rooting both sides? To cancel the square. Again, on the side with the variable, you are performing operations to simplify. On the right hand side, square root of 49 is 7. Continuing to work backwards, looking over at my left hand column, the opposite of subtracting 4 is adding 4. So I will use the golden rule to add 4 to both sides. Why am I adding 4? To cancel my subtraction, and 7 plus 4 is 11. Next, I'm going to check my answer, substituting 11 into my original equation for x. Order of operations. We already figured out what order of operations was here, so we don't have to really think about it again. 11 minus 4 is 7, and 7 squared is 49. I'm going to keep it running. I've only got one more example. If I knew what x was, I would first subtract 7, because it's in the parentheses, grouping symbols. Then I would square it, and then I would add 3. So we're going to follow these processes backwards and undo them. What's the opposite of adding 3? Subtracting 3. Why am I subtracting 3? to cancel my plus 3. Make sure on the side with the variable, I cannot say this enough, that you are using your operations to simplify. Don't make it harder on yourself, don't perform the operation, just use it to cancel. Looking at my left-hand column, to undo my square, I'm going to take the square root. Again, why am I taking the square root? To cancel my square and simplify. On the right-hand side, the square root of 81 is 9. Looking back at my left-hand column, the opposite of subtracting 7 is adding 7. So I will follow the golden rule and add 7 to both sides of my equation. Why am I adding 7 to both sides? To cancel my subtraction of 7, simplifying and leaving me with x, and 9 plus 7 is 16. So one last time, let's check our answer, substituting 16 in for x, and following order of operations. Inside the grouping symbols, 16 minus 7 is 9. 9 squared is 81. And 81 plus 3 is 84. And here are your U-try problems.